Welcome to my channel. Welcome my family. This is USA Fact Story, where mysteries become reality.
Look at any concept art for a permanent settlement on the Moon or Mars, and you will see massive feats of mechanical engineering. Habitats, rovers, and life support systems designed to keep the human body alive. But there is a glaring biological blind spot in all of those blueprints. Mammalian biology has spent the last few billion years evolving under the exact, unrelenting pull of Earth's gravity. Right now, we have absolutely no proof that human reproduction, and specifically early embryonic development, can successfully organize itself in the near-zero gravity environment of deep space. The obvious way to test this would be to send human embryos into orbit, but that crosses a massive ethical and logistical red line, making large-scale experimental testing impossible. Until researchers solve that biological barrier, the grand vision of humanity becoming a multi-generational, spacefaring species hits a hard physical limit.
We can build the habitats, but we don't know if we can populate them. That brings us to the recent successful launch of China's Tiangong 10 mission. Alongside the usual supplies bound for the Chinese space station, this specific spacecraft is carrying 67 scientific payloads. Tucked inside is the world's first complete space embryo research system. By dedicating mission space to this project, the scientific challenge pivots. The focus shifts from the mechanical physics of getting rockets into orbit to the biological engineering of sustaining early human life. To bypass the ethical roadblocks, scientists from the Chinese Academy of Sciences are using what they call artificial embryos. These are not true embryos, and they cannot develop into living human beings. They are highly complex structures engineered from stem cells that closely mimic real embryo development. This timeline shows the simulation, the highly vulnerable window between days 14 and 21 after fertilization. This is when the body maps itself out. Within days, major organ precursors form, and the human body axis locks into place. The margins for error here are microscopic. If any disturbance interrupts the process during this narrow window, it routinely leads to severe adult deformities and congenital heart disease. By sending these stem cell stand-ins to the space station, scientists finally have a proxy to watch the initial human architectural blueprint being drawn in real time. Solving the ethical problem immediately introduces a mechanical one. The team must execute a highly delicate biological experiment in orbit, millions of miles away from a sterile laboratory and a dedicated team of technicians. The Chinese space station provides the exact hostile variables that Earth cannot replicate: sustained microgravity paired with authentic, unfiltered cosmic radiation. Once aboard, the protocol is strict. The artificial embryos are set to develop for exactly 5 days, operating under the general supervision of the taikonauts on the station. The heavy lifting is handled by a closed-loop autonomous lab. Mechanical systems perfectly regulate the environment and replace nutrient solutions daily. There is zero room for mechanical failure. If the temperature fluctuates or the fluid transfer lags, the harsh conditions of space will kill the fragile samples before the test even concludes. Determining whether life can function in deep space depends on this machine running life support flawlessly for 5 consecutive days. At the end of that 5-day growth cycle, the automated systems stop the nutrient flow, concluding the active phase of the experiment. The immediate next step is rapid preservation. The onboard hardware meticulously freezes the delicate cellular structures right there in orbit. They do this to lock the biological data in place. Freezing the samples preserves their exact structural integrity, protecting them from the violent forces of re-entry so they can be transported back to Earth for a full laboratory breakdown. In an instant, active biology becomes a secure time capsule, carrying the first raw, uncorrupted data of zero-G embryonic development. When those capsules are opened at the Chinese Academy of Sciences, researchers know exactly what they are hunting for. They will scour the samples for specific signs of congenital abnormalities and cellular deformities. They are investigating the process of self-organization, testing if the absence of gravity disrupts the cell's ability to properly structure that crucial body plan. The researchers are looking far beyond simply cataloging the damage. The project manager, Yu Ken, notes that this data provides the baseline for an active counteroffensive. Once researchers map the specific vectors of damage caused by space, engineers and biologists can start developing targeted medical countermeasures and new habitat technologies to neutralize those exact threats. You cannot fix a problem until you know exactly how it breaks. Mapping the biological damage is the mandatory first step toward engineering a permanent cure for deep space reproduction. Which brings the focus right back to those grand, sweeping visions of permanent lunar bases and vast Martian cities. For all our advancements in rocketry, humanity cannot outlive Earth if we cannot safely birth new generations among the stars. Tiangong 10 has delivered the biological data that will determine if human life has a